We've gotten down to the nitty-gritty hands-on operation of the glass system. The MCP is our means of manually telling the AFDS or Autopilot Flight Director system what to do. These hands-on operations are important. Now let us not forget that it is equally as important to see visually what this system is doing. This is where the primary flight display comes in. Not only does it tell us exactly what the AFDS is doing, but it also gives us essential information in order to fly the airplane. As a pilot trains on instruments, typically he or she is scanning a large number of instruments to keep the aircraft flying in the correct condition. Aviation is always evolving, and instrument flying is at the forefront of this evolution. Flight displays are becoming more automated than ever. You would think only airlines could afford such technology. This is no longer the case. General aviation is seeing a widespread growth in the glass instrument area. The 747-400 and likewise the 777 were ahead of their time when Boeing placed this glass system in the aircraft. Now flying these complex aircraft was easy. For the first time, all the information was on this glorious screen appropriately named the primary flight display. Let's get intimate with this display. The primary flight display can be broken down into 6 different sections. These sections are the attitude indicator, flight mode annunciator, and that one should be familiar, airspeed indicator tape, altitude indicator tape, heading indicator, and vertical speed indicator. In order, let's start with the attitude indicator. Despite their wishes to the contrary, this is not a device for the first officer to work out the mood of the captain. The happy or sad captain gauge has not yet been fitted on our trusty Boeing 747-400, although we hear rumors of some airlines requesting this as an option. Don't be deceived. There is much more going on behind the scenes here than your typical horizon, ground, and sky, which you should be used to by now. Starting within the horizon window, let's break the basics down from top to bottom. The bank pointer derives information from our IRS, Inertial Reference System, to tell us the degree of bank. The degree of bank can be compared to the bank scale. The bank scale is 0 or level, 10, 20, 30, and 45 degrees. I can't imagine a situation where you'd go above 45 degrees bank angle. Below this bank pointer we find the slip skid indicator. This assists the pilot in coordinating the turns for passenger comfort and peak aircraft performance. A way to think of the bank pointer and slip skid indicator as a whole is to picture it as a sailboat. Line up the sailboat. When flaps are extended, a pitch limit indicator is shown. The pitch limit indicator is the point at which stick shaker will occur. Stick shaker is just as it sounds, a device that shakes the yoke to warn the pilot of an imminent stall. Do I really need to point out that stall is a bad thing? Discussed before, briefly, was the horizon. Well, here it is. Another important note are the pitch scale increments. These increments are 2.5 degrees. Assisting in our attitude awareness is the airplane symbol. It's not much of an airplane, but it does the trick. Not only does it help with getting wings level, but the middle dot is very useful when following flight director indications manually. Other indications commonly seen in this area are the flight director bars. These bars essentially give us pitch and roll commands based on what the auto flight system is doing or what we have programmed in the FMC. Now for some more complex indications seen in this area. These indications are seen during ILS, localizer, and other approaches. Because this is an instrument approach section, a couple things outside the box. First is the approach reference. Second is the selected course. Pretty straightforward. Capturing the wrong ILS, or flying the wrong course, is not a pilot's favorite thing to do. It does, however, automatically book you an appointment with the fleet captain back at the company office, who will be delighted to discuss the nuances of ILS with you before genially inviting you to fly with another company. Lucky for you simmers, you don't have to worry about losing your job. But stay on top of things. Now back inside the box. When passing marker beacons, they will show top right as a flashing signal. These also flash in cadence with the beacon identifier when it is tuned from the audio panel. The glide slope pointer comes into view when the glide slope signal is being received, and the glide slope scale comes into view when an ILS frequency is tuned. The pointer, also, will turn solid when within 2 1/3 dots from the center. The localizer pointer and scale operate exactly the same in respect to the localizer. This pointer too will turn solid when within 2 1/3 dots from the center. When on a localizer or ILS approach, a few more things happen when below 2,500 feet radio altitude. First is the altitude itself shown big and bold. Second is the rising runway. This runway helps us visualize how well we are lined up with the runway. It also begins to rise below 200 feet radio altitude to eventually meet the airplane symbol. How easy is that? As the runway symbol rises on the PFD, this becomes a great indicator of aircraft height above the real runway. Do not become too fixated on it and maintain forward vision too. That sudden thud as the landing gear compresses and all the cabin lockers bursting open, distributing their contents like wedding confetti, is a surefire indication that you have been looking at the digital concrete on the PFD and not the real concrete through the windows. To complete the attitude indicator are several more outside-the-box indications to note. The decision height, or DH, which will be top right. This is set on the EFIS, Electronic Flight Instrument, panel. By using the outer knob to select DH, the inner knob is then turned to select the appropriate DH. The same is done for the MDA, minimum descent altitude, which will be bottom right. The only difference is the outer knob must be on MDA. Last, top and center, is the mode of operation indicator. Here we will see command while an autopilot is engaged in command mode, FD when only flight director indications are being given, and autoland mode indications. There you go, the attitude indicator. Now that you know what each part means, it is much less confusing. This is the centerpiece of this system and the primary focus of the pilot, especially during an instrument approach. Section 2 of the PFD is the flight mode enunciator. This section should be simple, as we have already covered the majority of it. I feel no need to repeat myself on this one, as we've covered it quite a bit already. Now to a section that is vital to the lift of our wings and the integrity of the aircraft, the airspeed indicator tape. This important visual reference on the left side of the PFD gives us quite a bit of information. Your eyes are first drawn to the current airspeed. This airspeed stays central on the tape as the tape passes by. The MCP command speed is shown on the tape, or if the MCP window is blank, the FMC computed airspeed or Mach is marked. Connected to the current airspeed window is the trend vector. This indicator shows where the airspeed will be in 10 seconds based on current acceleration or deceleration. Command speed is shown outside the tape, sitting on top. This is either the MCP command speed or a programmed FMC speed. Mach speed, similar to the command speed, is located outside the tape but hangs from the bottom. The blank area of the tape is safe for maneuvering. However, maximum maneuvering speed, seen as yellow caution lines, sit at the top of this area. Just outside this area is the maximum speed based on the current aircraft configuration. Minimum speeds, much like the maximum speeds, are shown at the bottom. The speed tape also has a number of reference speeds for takeoff, flap operations, and landing. We will now discuss these reference speeds. First off, our takeoff reference speeds. On the speed tape, VR and V1 are shown. These indications are seen for takeoff only. When the speeds are out of range, they will show at the top of the tape and will not begin coming into view until the speed gets closer. After liftoff, these speeds disappear. Remember, if these speeds are not previously selected from the FMC, no V speeds will show in yellow. Flat maneuvering speeds are seen below 20,000 feet. The current flat maneuvering speed and lesser flat maneuvering speed are shown. When a landing VREF is selected from the FMC, it is shown on the speed tape and looks much like a takeoff V speed. Once again, what seemed like a complex section is now simple. Aren't you glad you didn't have to read and interpret all that? Keep the airspeed happy and you'll be the passenger's best friend. Otherwise, you'll end up falling out of the sky or breaking off parts. Neither sounds appealing. Next up is the altitude indicator tape. This tape is logical, just like the speed tape. Having all the information right here makes it very simple to read altitude, and quickly too. The selected altitude pointer is seen here, and shows the MCP altitude set in the MCP altitude window. When this pointer is out of range, it will rest at either the top or bottom with only half of the pointer visible. The MCP selected altitude is shown resting on the top of the altitude tape, between 300 and 900 feet before reaching the selected altitude. The box surrounding this altitude will be white. When meters is selected on the EFIS, it'll show right above this indication. Meters will also show above the current altitude when selected on the EFIS. Speaking of the current altitude, it rests here. This pointer is centered on the tape. Based on the barometric setting, the air data computers provide the appropriate altitude. When nearing a selected altitude, this pointer will flash white when 300 to 900 feet before the altitude. The last bit on the current altitude is the tens of thousands indicator. This will show, logically, when above 10,000 feet. Important altitudes would be those used for approach. Let's cover several of these features. When an MDA or DH is set by the EFIS, it will show on the altitude tape. A more accurate reading is shown out to the side, where the exact number is shown. For the DH, this would actually be shown at the top, just above the attitude indicator. The FMC landing altitude is shown as a crosshatch. This reading is made possible by entering in the destination airport's runway in the FMC. Important to lower-level flight is our barometric setting. Because this aircraft is a world flyer, we have both inches of mercury and hectopascals available. Let's go over how this is set and what we will see. A barometric setting is made on the EFIS panel. When pressing standard, the standard setting is shown. As was mentioned, inches of mercury and hectopascals are available. When a barometric setting is active, a yellow box will appear below the altitude tape if the transition altitude is broken. Remember to make the transitional changes between standard pressure and QNH. It can be both dangerous and embarrassing to find that you are flying with a different altitude datum to everyone else because you failed to calibrate your altimeter. You may end up losing more than just points for style. To clarify, setting standard will place a preset barometric setting made from the EFIS panel. The altitude indicator tape gets a little tricky when you start to deal with approaches. Other than that, like everything else on the aircraft, the indications are simple, straightforward, and leave little room for confusion. We're getting closer to the end, but we aren't quite done yet. Just a couple more and we will be done with the PFD section. So far we have discussed many things that to a mere mortal would seem pointless and mundane. We aren't mere mortals, we're pilots. This stuff is very exciting. The heading indicator is just about as simple as it looks. There are several fine points that make it very useful and separate this heading indicator from others. The heading pointer is centralized on the part circle. This heading is the IRS heading, based on the direction the aircraft axis is pointing. The track line is a very useful tool when flying an NDB or VOR approach. This is the line above the ground indicated by the FMC. The important difference here is wind drift angle. Selected heading is very obvious. This is the MCP selected heading. The selected heading is also seen as buck teeth when in range on the rim of the part circle. Last part of the heading indicator is the magnetic or true north reference. This is changed just above the upper ICAS when appropriate. To finish the PFD section, we'll have a glance at the three parts that make up the vertical speed indications. The vertical speed pointer was named appropriately. It points at the current vertical speed. Selected vertical speed, when in vertical speed mode, is shown as a tick and is changed from the MCP in 100-foot increments. Anytime the vertical speed is greater than 400 feet per minute, it will show above the vertical speed indicator when climbing and below when descending. Feeling overwhelmed? I'd say it is more of a relief to know what each thing does in these sections. Now you can use the PFD to aviate your way through your future travels. It may take a bit of time to get used to, as most of these components on the 747-400 require a bit of experience. That is normal. Just keep plugging away and review this section if needed. For the third section of the class, we will cover the navigation display, more commonly known as the ND.